In this video, we'll review the unit circle. We'll start by defining what the unit circle is, how it's derived, and then look at some easier ways to fill it in. So the unit circle is a special circle of radius 1 unit. The 1 unit is how it gets its name, the unit circle. Here's the circle with radius 1 unit. If we locate the center of the circle at the origin of our graph, we can locate some positions of some special points on the circle. We're going to start by finding the 4 quadrantal angles. The quadrantal angles are the angles that separate the quadrants and are also the x and y axes. On the extreme right-hand side, the coordinate's 1, 0. At the top, it's 0, 1. On the left, x is negative, so it's negative 1, 0. And at the bottom, y is negative, so it's 0, negative 1. To find other angles on here, we're going to need to use some special triangles. We're going to begin by using a 45, 45, 90 triangle. If we have a 45-degree angle of revolution in quadrant 1, the radius is still going to be 1, but we need to find the x and y values that go with this coordinate. Setting up a 45, 45, 90 triangle, we have legs of n and hypotenuse n root 2. Now, because the radius is 1, the hypotenuse is 1. And we're going to solve the equation, n root 2 equals 1. Divide both sides by root 2, and you get n equals 1 over root 2. Now, I don't leave the radical on the bottom, so I'm going to rationalize the denominator by multiplying top and bottom by root 2's. If I do that, I get 1 root 2 over root 2 times root 2, which is root 4, and the square root of 4 is just 2. Therefore, n equals root 2 over 2. Now, because both legs equal root 2 over 2, both the x and y values at this point are root 2 over 2. So the coordinate becomes root 2 over 2, comma, root 2 over 2. Now, I can find the coordinates of the same point in quadrants 2, 3, and 4 by simply changing the signs. We can reflect this triangle to the other 3 positions, and the signs of the coordinates just change. So when we move to quadrant 2, x is negative, so the coordinate becomes negative root 2 over 2, comma, root 2 over 2. If we reflect it down to quadrant 3, the y becomes negative also. And then when we go to quadrant 4, the x goes back to being positive. So knowing that 1 point really told me 4 points. Now let's use a 30-degree angle. If we have a 30-degree angle of revolution in quadrant 1, the x is going to be longer than y. We're more over than we are up because the x is away from the 60-degree angle and y is away from the 30-degree angle. X is the long leg. So in the 30, 60, 90-degree triangle, we have short leg, long leg hypotenuse in a ratio of n root 3 to n. Here, the hypotenuse is going to be the 1 because the radius is 1. Solving the equation, we get n equals 1/2. So the short leg, or the y, is going to be 1/2. The long leg is going to be 1/2 of root 3, or more commonly written as root 3 over 2. This means that the x, or the long leg, is root 3 over 2 because it's more over than it is up. The coordinate is therefore root 3 over 2, comma, 1/2. Now, knowing this 1 point actually helps me to find 4 points. In quadrant 2, that same 30-degree triangle can be reflected and x becomes negative. To go to quadrant 3, x and y's are both negative, and in quadrant 4, only y is negative. Now, if we rotate an additional 30-degree angle, we get a 60-degree angle. Now, we're not going to resolve this one because the 60-degree angle is really the same triangle as the previous one, it's just transformed. The short leg became the x and the long leg became the y. We're now more up than we are over. The y value is now away from the 60-degree angle, so it's the long leg. So we don't need to resolve it. All we need to do instead is just change the x and y coordinates. The root 3 over 2 now becomes the y piece, and the 1/2 becomes the x piece. So we know this coordinate is now going to be 1/2, comma, root 3 over 2. Notice what's in red here. The x and y just switched from the previous problem in quadrant 1. Now, knowing this point, we actually know 4 points. In quadrant 2, x is negative 1/2. In quadrant 3, x and y's are both negative. And in quadrant 4, only y is negative. Now, we're going to put this all together again. We're going to take our triangles and we're going to put them all in. But this time, we're also going to write the angles, too, that go with it. We're going to start with degrees. So the first angle we're going to do is 0 degrees, which has the coordinate 1, 0. The next angle is going to be 30 degrees up. At 30 degrees up, you're more over than you are up, so it's going to be root 3 over 2, comma, 1/2 for 30 degrees. If we go to the 45-degree angle, we're going to see that x and y are equal. So both x and y are root 2 over 2's. So we get coordinate root 2 over 2, comma, root 2 over 2 when the angle is 45 degrees. At the 60-degree angle, we're more up now than we are over, so the x value is smaller. So now it's going to be 1/2, comma, root 3 over 2 for 60-degree angle of rotation. At the 90 degrees, it's 0, 1. Adding another 30 degrees, we get 120 degrees. And that coordinate is really just the 60-degree angle with the x being negative now. So look at the 60 and the 120. You'll notice it's the same coordinate, but x is negative. Now the same is going to be true for the 135-degree angle as the 45-degree angle. It's going to be the negative root 2 over 2 and then root 2 over 2. And then the 30-degree angle of revolution, if we reflect that one over to quadrant 2, that becomes the 150-degree angle, and that becomes the negative root 3 over 2 comma 1/2. Now I'm going to do the same thing with the 0 degree. That becomes 180 degrees, and now x is negative 1, 0. To move to quadrant 3, we're going to take the values that are up in quadrant 2, but when we reflect them down, the y's become negative. So for 210 degrees, it's negative root 3 over 2 comma negative 1/2. Take the 135-degree coordinate, make x and y negative, that's the 225-degree angle. Take the 120-degree angle, make x and y negative, and that becomes your 240 degrees. The next quadrantal angle is for 270 degrees, and it's 0, negative 1. And now we're in quadrant 4. To find quadrant 4, we go back and make x positive, but we keep y negative. So in this next angle is going to be 300 degrees, and notice that the y is negative. It's the same as the 240-degree angle, except x is now positive. The 315-degree angle is the same as 225, but x is now positive. And the last one is going to be our 330-degree angle, but again, it's the same as 210, only x is positive. Notice in quadrant 1, x and y's are positive. In quadrant 2, x is negative and y is positive. In quadrant 3, x and y's are both negative. And in quadrant 4, only x is positive. Now let's do it again, but now let's do it in radians. When we go to radians, the coordinates don't change. The coordinates stay whatever they are. So we'll see 1, 0, root 3 over 2 comma 1/2, and so on. But it's the angles that change. We're going to express all these angles in radians instead. So to begin with, 1, 0 is now for either 0 or 2 pi. The 30-degree angle becomes pi over 6. There are 6 30-degree angles that make up 180 degrees. 180 degrees is pi in radians, and each of those 30-degree angles is 1/6 of that pi. Hence the angle pi over 6. The 45-degree angle becomes pi over 4. There are 4 45s that make up 180, so each of those angles is 1/4 of pi, hence pi over 4. 60-degree angles are twice as big as a 30-degree angle, so 2 times pi over 6 becomes pi over 3. There are 3 of the 60-degree angles that make up 180. Each is therefore 1/3 of pi. 90 degrees becomes pi over 2 because each 90-degree angle is half of 180, or in radians, half of pi. The 120-degree angle becomes 2 pi over 3. The 135-degree angle becomes 3 pi over 4. The 150-degree angle becomes 5 pi over 6. And then the 180-degree angle is pi. In quadrant 3, the 210-degree angle is now 7 pi over 6. It's 1/6 more than pi. This is now 5 pi over 4. And the 240-degree angle becomes 4 pi over 3. The 270-degree angle is now 3 pi over 2. The 300-degree angle is 5 pi over 3. The 315-degree angle is 7 pi over 4. And the 330-degree angle is 11 pi over 6. Now you may see some patterns here. If you look at the angles that are closest to the x-axis are going to be the pi over 6's. So what were 30-degree angles are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. The angles that were some reflection of 45 degrees, which have the same x and y values, will now be something over 4's. In the middle, we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The angles that were more up than they are over, which were 60-degree angles, are now pi over 3's. So we get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. This is one of the patterns that will help us to speed up filling in the circle. Now let's look at some other patterns here. If you notice, like I said, the 45-degree angles, these are the ones that are over the same amount they are up. So anytime you have something over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, the coordinates will have the same x and y values, only the signs change. In quadrant 1, they're both positive. Quadrant 2, x is negative. Quadrant 3, they're both x and y negatives. And in quadrant 4, positive x, negative y. For a 30-degree angle, or in radians, pi over 6s, you're going to notice that you're more over than you are up. Because we're more over than we are up, x is bigger than y. Therefore, the x will be the root 3 over 2's for all these coordinates, and the y's are going to be 1/2. The only difference between those 4 points is the signs. In quadrant 1, again, they're both positive. Quadrant 2, only x is negative. Quadrant 3, they're both negative. And in quadrant 4, only the y is negative. For what were our 60-degree angles, or now pi over 3's, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, we're now more up than we are over. Because we're more up, the y values are bigger now, in which case you'll notice that for all 4 of these coordinates, the y's are the root 3 over 2's, and the x are only the 1/2's. And again, one more time, in quadrant 1, x and y's are both positive. Quadrant 2, only x is negative. Quadrant 3, x and y's are both negative. And in quadrant 4, only the y is negative. Now, we can use this to fill it in. And the way I usually fill in the unit circles, I start by filling in the quadrantal angles. I'll fill in those 4 ones that separate the different quadrants. Those are my ones that have just the zeros and the ones. Next, I'll fill in my pi over 4's. That would be these 4. The pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And again, I remember at the pi over 4's, x and y's are equal, which means they're root 2 over 2's. Only have to watch for changing the signs. Next, I'll fill in my 60-degree angles, or my pi over 3's. That would be these green ones. That would be the pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. For these angles, we're more up than we are over, which means the y's are the bigger pieces. That means the y's are the root 3 over 2's, and the x are 1/2's. Lastly, I'll go back and I'll fill in my 30-degree angles, or in radians, my pi over 6's. These are the blue ones. The one on the right top would be pi over 6. In quadrant 2, 5 pi over 6. Quadrant 3, 7 pi over 6. Quadrant 4, 11 pi over 6. For these, we're more over than we are up, which means now the x is bigger. So these ones start with the root 3 over 2 and have the 1/2 for y. And again, all we need to do is change the signs. So that's how I'll fill it in. I'll do my quadrantals, I'll do my over 4's, I'll do my over 3's, and then do over my 6's. If I do it this way, I don't ever have to reduce a fraction. I can just fill them in and do it very quickly. Now there are some other patterns that are handy to know. If you look at the y values, and we're starting at the 0, or 1, 0, starting on the extreme right-hand side, if you look at the y values, you'll notice that they're increasing. It goes from 0 to 1 on top, to 2 on top, to 3 on top. This is because we're getting more up as we revolve around the circle in a counterclockwise direction, starting from the extreme right. So one pattern is to do this and say it's 0, the square root of 1, square root of 2, square root of 3. Now the square root of 0 is 0, and the square root of 1 is 1, which is why those don't have the radical. And the pattern actually does continue to the top number where it says 0, 1. That's really, if we follow the pattern, root 0, root 1, root 2, root 3. The next one should be root 4. The square root of 4 is 2, and 2 over 2 would give me that 1. Now looking at the x's, the pattern works in the other direction. If we start at the top, that is in blue now, where x is 0, it's at the center, it gets bigger as we go to the right. That means we're getting more away from the origin. So if you notice the pattern here, x's get bigger as you go to the right. So x is in blue here, 0, and then it's the root 1, root 2, root 3, and then the square root of 4, which is 2, 2 over 2 is 1. So the pattern for the y's, it increases as you go up, 0, 1, 2, 3, but the x values get bigger as you move from the top to the side, 0, 1, 2, 3 in blue. And that's just another pattern some people use to fill these in. All right, thank you for watching this video, and hopefully it helps you understand how to fill in the unit circle.